Hi, my name is Anthony Russo, and this is my pollutant presentation on vinyl chloride for environmental chemistry on November 22nd, 2021. History and chemistry. Vinyl chloride was invented in 1913 by Fritz Klatt when he mixed together hydrochloric acid and acetylene in his lab, and it released a gas. It is composed of two carbon atoms with three hydrogens and a chlorine attached. Therefore, its formula can be written as C2H3Cl. Another name for it is chloroethene. Another is vinyl chloride monomer, or VCM. Vinyl chloride molecules, abbreviated as VC, are often formed into polymers like polyvinyl chloride, which you may have heard of as PVC, a very common plastic. 98% of VC, or vinyl chloride, is made into PVC. Distribution. About 16 billion pounds of vinyl chloride are produced each year, and that figure continues to grow by approximately 3% annually. To put things in perspective, it's a gas. Gases have tremendously low densities, therefore 16 billion pounds is a tremendous volume of this material. Most PVC production, and therefore most VC, or vinyl chloride production, occurs in China. The United States is the second largest world producer. Therefore, most vinyl chloride pollution comes from China and the USA. It can travel long distances in the atmosphere. It is more highly concentrated in and downstream of industrial areas and cities. It's less concentrated in isolated or undeveloped areas, but it's still present there due to atmospheric transport from the higher concentration areas to those of lower concentration. Properties. Vinyl chloride is a gas, and it has a very low boiling point and high vapor pressure, leading it to evaporate very rapidly if left in a liquid form. It's colorless and flammable, and it has a sweet odor. It can be suspended in solution with other gases, or in solution of a liquid, or it can be bound up in a solid, and it would slowly get released from that solid. Vinyl chloride molecules are often formed into polymers, like polyvinyl chloride, PVC, mentioned earlier, which is a very common plastic. PVC can be found in a variety of products which we are exposed to and interact with throughout our daily lives. One of these products is PVC piping, which is used in a lot of homes. Leading us into uses. VC, vinyl chloride, is used in cosmetics, aerosols, refrigerants, plastics, and those plastics it's used in can be used for PVC pipes, for wire coatings to insulate the wires, for upholstery of furniture, for kitchen utensils such as bowls, spoons, Tupperwares, etc., and food packaging items. On the graphic here, you can see that vinyl chloride was commonly used in cosmetics previously, but although it was used in cosmetics, refrigerants, and household aerosols, it's not used in those things anymore because people have discovered that it's harmful. One recommendation here given by the graphic is to limit use of PVC plastic containers in food packaging because they have traces of vinyl chloride. This can be referenced back to the statement earlier about how when the vinyl chloride is bound up in a solid, such as PVC, small amounts of it can be released over time. Those could theoretically get into food and drink that are stored within these containers and lead to illness in the people who ingest that food. Exposure. Industry and goods. VC is emitted into the air at landfills and facilities that process and use vinyl chloride. The US EPA reference level of 0.04 ppm can cause harm. Air at landfills can have up to 44 ppm concentrations. This is 1,100 times the reference concentration. Wow, that's a lot. Industrial workers can be exposed to tremendously high levels of it at petrochemical and plastics facilities. Many household items and goods are made with PVC, polyvinyl chloride, and these items typically have trace amounts of vinyl chloride that is left in or on them. PVC water pipes in homes can contaminate water supplies with vinyl chloride as well. Exposure. Vinyl chloride in the environment. Air and water near places that manufacture and process vinyl chloride, along with air and water near landfills and other industrial areas, can have high levels of vinyl chloride in it. Thankfully, vinyl chloride does not appreciably biomagnify to any extent, and it does not appreciably bioaccumulate either. So once exposure is reduced, the levels of vinyl chloride within the organism are also reduced. Health effects. The immediate reaction to inhalation or ingestion can lead to drunkenness, loss of muscle coordination or control, and even unconsciousness, depending on the extent of the exposure, both in time and in concentration and dosage. Vinyl chloride may have immunosuppressive or immune system altering properties, which warrants further study. After exposure, it can be found by tests in the brain, liver, spleen, kidneys, fat, and muscle tissues. The highest concentrations can be found in the liver and kidneys because these are what filter it from the blood. Vinyl chloride is a known carcinogen. Therefore, having it in any of these locations is very bad. It causes liver cancer mainly, although there are other kinds it can also cause. The two types of liver cancer which it most commonly causes are liver angiosarcoma and hepatocellular carcinoma. Remediation. Vinyl chloride can be oxidized by chemicals or by bacteria. One way to increase oxidation of it by bacteria is to add aeration to the environment, whether it's adding aeration stones or flow devices into a pond or a lake that's contaminated, or by pumping air down into wells. It can also be released from soil or water by heating it up. The problem with that, though, is that it's then released into the atmosphere. One way that can be extracted from soil is soil vapor extraction. As a sample of soil is warmed, the vinyl chloride vapor that is let off can be captured to be disposed of. But this is harder to do on a larger scale because you can't exactly heat a large portion of ground under a controlled setting and collect all of the vapor. These are my references. I hope you've learned something about vinyl chloride and how it can affect our lives.